Hello and welcome back. My name is Amir and this is project 23 on the project-euler series. This is like about 800 different projects that I'm going to solve one after another. So let's go to 23 and see what we are facing for today. Right, a perfect number is a number for which the sum of its proper divisors is exactly equal to the number. For example, the sum of the proper divisors of 28 is 1, 2, 4, 7, and 14, which add up to 28, which is the number. Now this shows that 28 is a perfect number. Number n is called deficient if the sum of its proper divisors is less than it. And it's called abundant if the sum exceeds n. So for example, all the prime numbers will be deficient because the sum of their proper divisors will be all 1. So for example, 29 will be a deficient number. So as 12 is the smallest abundant number, yes, because 1, 2, 3, 4, and 6 becomes 16, which is greater than 12. The smallest number that can be written as the sum of two abundant numbers is 24 because it can be written as 2 12s. Right. By mathematical analysis, it can be shown that all the integers greater than 28, 1, 2, 3 can be written as the sum of two abundant numbers. Okay. This upper limit cannot be reduced any further by analysis, even though it's known the greatest number that cannot be expressed as the sum of two abundant numbers is less than this limit. Okay, so find the sum of all the positive integers which can be written as the sum of two abundant numbers. Right, so it's a multi-step process. First, I need to say that my limit is 28, 1, 2, 3, this number that is being given here. Then I will find all the abundant from 1 to this number, and then I will check that from 1 to 28, 1 to 3, is there a number that cannot be written by those abundant numbers that I have found. And when I found those numbers, then I will add them up and will provide the result. So let's go and write the code. So first I would say my limit is this value. Then I would try to populate the list of abundants. So okay, now I need to write this function. I need to check the divisors less than that number and then add them together. So and in the end I would say that if sum is greater than n, then it's an abundant by the definition here. So now I think that I have the list of the abundants, so let's log that. Yes, I have 12, 18, 20, 24, and so on. Okay, so this is working fine. Let's clear it. Now, the thing that I need to do now is to have an array from 1 to this limit, and I will fill them with false value, and then I will go to the list. So let me run it again. I will go through the list and will try to add these together. So I would say 12 plus 18 is 30. So in my list, 30 should be true, and so on. 12 plus 20 is 32. So in the list of all the falses, 32 would be true. So when these checks are done, then I can say that which of those values can be written as abundance and which cannot be written. So let's write that part. So now if I run this and log this value, then I will see a bunch of trues and false. So it will probably be that from 1 to 11 I would get a bunch of false. Then 13, 14 to 18 will be false, and so forth and so on. So let's see. Yep, you can see all of these values are false until we get to 12 plus 12, which is 24. So when I'm checking this, I can see that 1, 2, 3, 4, 5, 6, 7, 8, 16, and 24 is this one. Yep, 24 is true because 24 can be written as 2 12s. So that is true. Now I need to loop through this massive array of false and trues and then add those that are false. And not the value of false, but the index. Index 0 is false, index 1 is false, so 0 plus 1 plus 2 plus 3 plus 4 all the way to 23, and then so forth and so on. So let's do that then. And I don't want this anymore. So I would say I'm checking that if the value is true, then I don't need to add it, so add 0, and if value is false, then add the index. So let's see the result here. Right, yes, this is correct. I recommend you to go through the code here and check it again and try to write it by yourself and see if you can come with better ideas or not. Thank you again for watching, and see you in the next video then.